these are the special products. And so as you go through these, really try and work these out and see if you can see certain patterns. Now we have x plus 3 times itself, x minus 3 times itself, and then x plus 3 times x minus 3. And I'm noting that the long way always works. So these first ones I'm going to do thoroughly and really take more time than we might be able to take on these later on. So let me zoom in to where I see x plus 3 squared. I won't do this all the time, but since this is a new idea, I'll do x plus 3 times x plus 3. And I'm assuming that foiling's pretty comfortable, so I'm just going to write x squared plus 3x plus 3x plus 9. So if that's not clear, you need to stop this video right now and make sure you work that out. Now the cool thing is that these ended up being the same. So the outer and the inner agreed. So that means this showed up twice. And that means I can really have just done 2 times 3 to get 6. And then plus 9. I've removed the work from the first one so that I can zoom in on the second example. Now I'm going to have x minus 3, and I'm saying the long way always works, so as you take these notes, write these out the long way for this top section. I have x minus 3 times x minus 3, which is going to FOIL out to x squared minus 3x minus 3x, and here we have a negative times a negative to give us a plus 9. The same way that these guys showed up twice positively, they're now showing up twice, but they're becoming a minus 6x. I'll fill in the other pieces. The same way that this 9 showed up, it's showing up as 9 again. And really the reason is because in both examples, when we go to the last, 3 times 3 gives us a positive number, because we're always going to have a positive times a positive. And then in this example, we're always going to have the negative times a negative. So again, this will also be a positive. Now before we move on to that third one, let's look at what this means for what's going on here. The square of a sum means that I'm going to take a number a plus b and I'm going to square it. In our examples, when we multiplied that first number times itself, it became squared. So that means that the a term will get squared. Now then, the inside part, there was where we basically had 3x showing up twice. So it's always going to be this number times that number, but then doubled. So here we write AB, but times a 2, so 2AB. And then for those last, we just get that final term multiplied by itself. And I'm thinking that's pretty clear. Moving on to the square of a difference, well, difference means subtraction, so I'll write A minus B. I'm going to square it, and I'm going to get A squared minus 2AB plus B squared. When I look for these patterns, it's like, oh, it feels fine to me because that was a positive, so both of these terms end up being positive. We get a positive times a positive to give us this last term. I'm all right with that. And the same deal here. I can figure out why this would be a minus and that a plus. I feel comfortable with it. And like I say, until these are really comfortable, you could do this both ways. You know, try using the formula from memory, but also expand it out and do it all on your own that way too. Because you'd be like, well, hey, they agree. Now we still haven't done that other one yet, and that's fine. So these say 4, find each. Now you'll notice what makes these more challenging is that you don't just have y here, but you have 4y. So it's always going to be that first term squared, and so I put it in parentheses just to be cautious in case there are negatives, plus twice 4y and 5, plus 5 squared. Now notice that I wrote this in red because I don't want you to have to write that. Because usually I'd just be like, well, okay, we got 4y squared. It's going to give me 16y squared, and I'm keeping an eye out for that negative. And then maybe I'm just like, well, 4 times 5 is 20, and then I get double that is 40y plus 25. But I wanted you to see the way it gets written, because it would have to be this entire term squared, which would be uglier for this example. Let's see what happens when we try to just use the actual rule. So here's 4y plus 5 all squared. And that means that this is going to be the square of a sum. So here's the formula that I'm going to get out of this. I'm going to rewrite this in the top right corner, so that it's there for reference. But what this means is that whatever I see here for a is all getting squared. And to guarantee that I square the whole thing, I'm going to rewrite 4y in parentheses. That way it helps me see that it's not just y getting squared, because if I only wrote 4y squared, these two things are not the same at all. And then I move on and do plus 2 times a and then times b. Now, if there are negatives and things like that, I definitely want to make sure I'm showing that. But I really don't need this in parentheses unless I like it for some reason. So I'm going to write times 4y and then times 5. And then I move on to the b squared part, which is 5. And I'm just going to do 5 squared. If this were a negative number, I would have snuck it in parentheses. Or if it was something more complicated, I might put it in parentheses. All right, so 4y squared simplifies to 16y squared, plus 2 times 4 is 8 times 5 is 40, y plus 25. I scan through that, but most of the time, these will be simplified right away. Here's another example below. You can do this one on your own and compare it with what I put up in just a few seconds. My answer is 9x squared plus 24xy plus 16y squared. If you didn't get that, it's probably because you didn't include this in parentheses, or maybe this in parentheses, which would give you that 9 and 16 once you square the 3 and the 4. Or maybe you didn't have xy here because this problem added on variables on the left and right, as opposed to in the problem before that only had a number. Let's move on to the subtraction example. Here's 6p minus 1 squared. And for reference, I'm going to write the square of a difference on this right side. So there it is, a squared minus 2ab plus b squared. So this means that the 6p gets placed in parentheses, squared. I have to use a minus sign, because that's the formula, times with 2 times 6p times a 1. Now, there's your formula coming into play. I don't have to write times a negative 1, because there's nothing strange going on there. That would give me my subtraction. And it's always going to be plus b squared, and since that b matches up with that 1, and this minus is in front of it, there's really not, b is not equal to negative 1, it's just 1. So then I'm going to write plus 1 squared. Probably fine jumping right to writing 1 there, but just showing all the steps to be cautious. 36p squared minus 12p plus 1, and we can box that guy. And just to kind of show you what will come, you'll have to do these problems later on where you go from this to that. You'll have to factor things out. So right now we're multiplying things, but later on we'll be factoring. So instead of going in this direction, we'll go in that direction. Here are a bunch of examples, and make this one on your own. Oh, yo. Show the answer in just a moment. 64c squared plus 48cd plus 9d squared. This one, however, is a little bit more ugly. So let's try this one together. This is going to be 5m cubed in parentheses because that entire thing would match up with my original A minus B format. So A is the whole quantity of 5m cubed. All of that makes A. Then I'm going to attach the squared sign. But be careful as your eyes are jumping back and forth. Don't write cubed and don't confuse these things. The next thing to do is to write minus 2 times A, which is 5m cubed, times 2n. Because that entire thing here is B. That entire 2n, because it's in front of the minus sign. I'm sorry, after the minus sign. And then with this formula, as well as the other one, it's always going to be plus b squared, which in this case is 2n squared. And hopefully, as we do these, it's really apparent and clear that these exponents need to be attached to the parentheses. So that we get 25m to the 6. Now notice that I'm not talking about why that is the way it is. It's assumed that that's comfortable now, times minus 20, because 2 times 5 is 10 times 2 is 20, m cubed n plus 4n squared. If you have questions, maybe star these and write them down. This next one's also ugly. If you want, you can pause it and try it on your own and see how it goes. But it's almost like by using the variables a and b, it's like they're trying to mess with you a little bit. So this whole quantity a, I don't really need parentheses because it's just by itself. So I won't bother showing parentheses. A squared minus, the formula says to use 2 times a, which in this case is on the left, and is a already, times b, which in this case is 2b. So I move on to the last part, and I'm going to do plus, but I do need this in parentheses, 2b squared. And when I simplify, I get a squared minus 4ab. That's a real common place to make a mistake. If there's a third number, maybe you only multiply the 2, and you forget to leave the other one on there as well, plus 4b squared. So always scan through these for a second time to see how they go. Now here's a little tip. If you know that's going to mess with you, rewrite it as x minus 2y and do the problem, and then just substitute back in a and b or whatever by the end of the problem if your teacher is very particular about that. But yeah, if you know it's going to screw with you, go ahead and change it. Product of a sum and a difference. That will start here, and we'll save that for the second video.